Welcome to another episode of Vox AI News. I'm Alice, and I'm thrilled to be here with my co-host, John. How are you doing today, John?
Hey, Alice. I'm doing great, thanks. Excited to dive into today's topic, which is all about the recently introduced Mixtral 8x7B model. It's a fascinating development in the world of AI and natural language processing.
Absolutely. So to kick things off, could you give us a brief overview of what Mixtral 8x7B is and how it differs from previous models?
Sure. Mixtral 8x7B is a sparse mixture of experts, SMoE, language model. Unlike traditional models that utilize all their parameters for every token processed, Mixtral uses a routing mechanism to select only a subset of its parameters. Specifically, it selects 2 experts from a pool of 8 for each token, allowing it to achieve a remarkable balance between efficiency and performance.
That's interesting. Can you explain the significance of using a sparse mixture of experts architecture?
Of course. The Sparse Mixture of Experts architecture allows the model to maintain a high number of parameters, 47 billion in Mixtral's case, while only activating a fraction of them, 13 billion, during inference. This leads to faster processing speeds and reduced computational costs, especially beneficial when dealing with large batch sizes.
So it seems like Mixtral has a unique approach to handling large amounts of data. How does it compare to other models like Llama 2 and GPT 3.5?
Great question. Mixtral has been shown to outperform or match Llama 270B and GT3.5 across various benchmarks. For example, it excels particularly in mathematics, code generation, and multilingual tasks, areas where it significantly outperforms Llama 270B.
What kind of benchmarks are we talking about here?
Mixtral was evaluated on a wide range of tasks, including common sense reasoning, world knowledge, reading comprehension, mathematics, and code generation. It has demonstrated superior capabilities in these areas, particularly in mathematics and code generation benchmarks.
That's impressive. Can you explain how the routing mechanism works in Mixtral?
Certainly. The routing mechanism in Mixtral involves a router network that selects 2 out of the 8 experts for each token at every layer. This selection is based on the input token's characteristics, allowing the model to dynamically choose the most relevant experts for processing.
How does this dynamic selection of experts affect the model's performance?
The dynamic selection allows Mixtral to adapt its processing capabilities based on the token it is handling. This means that for complex tasks, it can leverage the experts that are best suited for the specific context, leading to improved output quality and efficiency.
You mentioned that Mixtral has a context size of 32K tokens. Why is this significant?
The 32K token context size allows Mixtral to handle long sequences of text more effectively than many other models. This is particularly beneficial for tasks that require understanding or generating long-form content, as it can retain and utilize a vast amount of contextual information.
Can you elaborate on how Mixtral performs in multilingual tasks?
Absolutely. Mixtral was pre-trained with a significant amount of multilingual data, which enhances its ability to understand and generate text in multiple languages. It has shown superior performance compared to Llama 270B in languages like French, German, Spanish, and Italian.
That's quite an achievement. How about its performance in bias benchmarks? How does Mixtral compare in that regard?
Mixtral has shown to exhibit less bias compared to Llama 270B in various bias benchmarks. For instance, it achieved a higher accuracy on the BBQ benchmark, indicating that it performs better in generating responses that are more balanced and less biased.
What about the fine-tuning process for Mixtral? How does it work?
Mixtral underwent a fine-tuning process known as supervised fine-tuning, SFT, followed by direct preference optimization, DPO. This process helps the model better follow instructions and respond appropriately to user queries, making it more effective in conversational settings.
Can you explain what direct preference optimization is and how it benefits the model?
Direct preference optimization is a method that refines the model's responses based on user feedback. By training the model to prefer certain types of responses over others, it can produce outputs that are more aligned with user expectations and preferences, improving overall user satisfaction.
So, what can we expect in terms of applications for Mixtral?
Given its capabilities, Mixtral has a wide range of potential applications, from automated customer service to content generation, programming assistance, and even educational tools. Its multilingual abilities also open doors for global applications.
What are the implications of releasing Mixtral under the Apache 2.0 license?
Releasing Mixtral under the Apache 2.0 license means it is available for both academic and commercial use, promoting collaboration and innovation in the AI community. This accessibility can lead to diverse applications and further advancements in the field.
How does Mixtral's architecture contribute to its efficiency?
Mixtral's architecture, particularly its sparse mixture of experts design, allows it to maintain a high parameter count while only activating a small subset during inference. This results in lower computational costs and faster processing times, making it more efficient than many traditional models.
Can you share some examples of tasks where Mixtral excels?
Sure, Mixtral excels in tasks such as solving complex mathematical problems, generating code, and performing language translation. Its ability to manage long context and dynamically select experts makes it particularly adept at these tasks.
What challenges do you think Mixtral might face in the future?
One challenge could be the need for continual updates and training to keep up with evolving language use and emerging data. Additionally, as AI models grow more complex, ensuring they remain interpretable and ethical will be crucial.
That's a great point. How does Mixtral handle the issue of bias in AI models?
Mixtral's design and training process include measures to reduce bias. By evaluating its performance on bias benchmarks and fine-tuning it accordingly, the developers aim to create a model that generates more balanced and fair outputs.
What do you think the future holds for models like Mixtral?
The future looks promising for models like Mixtral. As they continue to evolve, we can expect improvements in their capabilities, efficiency, and ethical considerations. This could lead to even more innovative applications across various industries.
Before we wrap up, is there anything else you'd like to add regarding Mixtral?
Just that it's exciting to see how the AI landscape is advancing with models like Mixtral. It's a testament to how far we've come in natural language processing and the potential for future developments.
Absolutely. Thanks for such a thorough discussion, John. Let's summarize what we've covered today.
Sure. We explored the Mixtral 8x7B model, its sparse mixture of experts architecture, its performance across various benchmarks, and its potential applications. We also discussed its efficiency, bias handling, and the implications of its open-source release.
Thanks for joining us today, everyone. We hope you found this episode insightful. Stay curious and stay informed. We'll catch you on the next episode of Vox AI News.
See you next time.